So this is section 7.2 in our textbook on confidence intervals. So a confidence interval is just telling us where we think a population parameter is, and that is a statistic. In this case, the proportion is the parameter in question. And we're just trying to figure out what we're making an educated guess, a very educated guess, using a formula to figure out where that value is. So our answer is going to be an interval. And we're going to be a certain degree of confidence, say 95% confident or 99% confident, not 100% confident. We're never 100% confident that we have it. That would mean we just have the true population parameter. So the thing about the population is that we just don't know. Some populations can be so large that we have no way to know what a particular proportion actually is. So we take a sample. And if we do the sample correctly, a random sample, then that sample can represent that population very, very accurately, or at least, within a certain margin of error. And so that's what we're going to talk about today, how to find out what that margin of error is, and then how to put it into a confidence interval. So you have a reference sheet, and we're on the top of the back of your reference sheet with the confidence intervals. And we have, we're going to use the top ones first, and this is in regard to a proportion. That first little letter there is a P with a hat on it, and we call it P hat. Then we have a Z, which you're pretty familiar with. We're going to get a little more specific about what that is. And then we have P and Q hat. We've done P's and Q's before, so I think you probably will know how to get the Q. And N. N is the number in the sample size. So what I've done for this lesson is broken down the formulas a little bit. Again, these are the two that we're going to work with, and want to talk about how you get each value in a particular set. So P hat, again, is formed by a sample that we've taken, and we know how many is in the sample, and X is our number of successes in that sample. Q hat is just the complement of P hat, or 1 minus P hat. And then we have this capital E. So capital E does not appear there, but we are taking out this portion and calling it E, which is your margin of error. Now notice that that margin of error is being added and subtracted to the sample statistic, P hat. And here I'm showing that as a simplified formula where you have your P hat and you add and subtract some margin of error. So we've got to figure out what that margin of error is. I'm going to start this by just doing an example and showing you how all the math works. Okay, so the first example is we're told to construct a 99% confidence interval for the population proportion and interpret the results. Okay. Have you ever seen a ghost? In a survey of 4,013 U.S. adults, 722 say they have seen a ghost. Yes. I know, it's weird. I agree. My daughter's new boyfriend says he's seen a ghost, and that it touched his toe. I'm going, okay, all right, you sure? You sure about this? I'm asking my daughter, are you sure? A ghost? Okay. All right. Well, there we go. All right. So let's pull out the important information. First of all, one of the most important things you need to know is that the sample size, and that was the 4,013. So sample size from here out for the rest of the year is called N. And N equals 4,013 here. Okay, because we are interested in who saw a ghost, that is our value X. So we create P hat by going X over N, and that will be 722 over 4,013. So just a quick calculation. And I like 3 decimal places, so 0.180. It's 0.1799, so I'm going to round that to 0.180. So that's my P hat. If that's P hat, Q hat is just the complement of that. So really that's 18 or 18%. So Q hat is going to be 82%, or 0.82. So we have almost all the numbers we need. We have N, we have P hat, we have Q hat. Now we need to talk about Z. We've done Z scores, and this is similar in that it has to do with a normal distribution. But these are called critical values. This Z is a critical value. And we find this on a new table. You got a new table, class. So everybody, if you have that table, you can pull out that table and we'll talk about this. It's the T-distribution table, but it has some information on it in regard to confidence intervals with the Z. And so I want to draw your attention to this first row. It's called the level of confidence. And notice that we have a little picture there with a distribution that's similar to the normal distribution. And it's showing us values between two, in this case T's, but they're also between two Z's. And so we're going to look up those Z's. But the good thing about this table is that we have this level of confidence, and it gives these percentages. So we are looking for a 99%, which is 0.99, and then we're going to drop all the way down to the bottom of the table where it's labeled Z. And so the value for the Z at 99% confidence is 2.576. After a while, you'll get to where you know what some of these numbers are. You've used them so many times. 2.576. This is for 99% confidence. Okay, 99% confidence gives us 2.576. Now, looking at the formula again, we have everything we need to find that margin of error. So, the margin of error is Z times square root of P hat Q hat over N. So this is 2.576 times square root 0.18 times 0.82 divided by 4,013. Okay. You can put this all in your calculator at once. 2.576 times square root 0.18 times 0.82 divided by 4,013. Remember to close your parentheses after you put the whole fraction in there, not before, because that's what's the square root of everything that's in the parentheses for this kind of calculator. And that will be 0.016. 0.016 for the margin of error. Okay, so that's our E. Now remember, I simplified this formula to be P hat plus or minus E. So I've run out of room right here. Finish this problem up. So with P hat plus and minus E, we will have 0.18. I like to do the minus first, 0.016 minus 0.016 and 0.18 plus 0.016. And again, we just need to add and subtract these. So 164 and 196. We express this as a in a set of parentheses, the lower number first, and then the higher number. And this is our confidence interval for the proportion of U.S. adults who have seen a ghost. All right, this question also asks for us to interpret this confidence interval. So I'm now going to write an interpretation. And this interpretation that I'm about to write is what you're going to write every time, a similar interpretation using a similar kind of statement with these numbers. So if you haven't already, you should jot down this little sentence. So we're going to say, with 99% confidence, the proportion of U.S. adults who say, and again, I'm pulling the words right out of the problem, who say they have seen a ghost falls between, and here's where you put your interval. You can express it as a percentage if you want, especially if the question asks for what percent. In this case, it doesn't really, it says population proportion, so I'll put the proportion. Between 0.164 and 0.196. And that is our interpretation of this confidence interval. So again, with 99% confidence, the proportion of U.S. adults who say they have seen a ghost falls between 0.164 and 0.196. So we're not completely 100% sure, but we're pretty close to being sure that the true proportion that we cannot know, even with 4,000 people in our sample, we're talking about millions, hundreds of millions of U.S. adults. We can't possibly know what that true proportion is, but we can make a good guess that it falls between these two numbers, about 16% and 20%. A lot of people. Okay, so that was one complete construction of a confidence interval with an interpretation. Let's see, I think I have another one I want to do. This one is about nail polish. I picked this one. I thought you girls might like relate to this. Okay, so in a survey of 7,000 women, 4,431 say they change their nail polish once a week. We're going to construct the 95% confidence interval for the population proportion of women, all women, who change their nail polish once a week. Okay, so this came from some cosmetic company, I guess. 7,000 women, and they don't even say U.S. women or what, or whether they're, Florida women or U.S. women or, I don't know. Anyway, so I don't know if it's everybody or not. Yeah. Go ahead. Okay, so we need to pull out the important values out of the problem. So first of all, N is going to be the 7,000. That's how many are in the survey. Our X, or number of successes, will be 4,431. We will use that to find P hat. So 4,431 divided by 7,000. Is 0.633, again using 3 decimal places. Q hat then is the complement of this, or 1 minus that, 0.367. So you can always check and make sure you have it right by adding those two to make sure that they add up to be 1. Okay, we also need Z. The critical value here, Z, for 95%. Let's go to the table. The top of the table, under 95, and then all the way down to the bottom where it says Z, is 1.96. So 1.96 is the value, the critical value we will use. Please make sure one of the most common errors is using 0.95 instead of looking it up and finding the Z-score. Okay, very big difference between these numbers, which would create an error. Okay, now time to find the margin of error. Margin of error is going to be Z, 1.96, times the square root of 0.633 times 0.367, all divided by 7,000. And that .011. So a very small margin of error there. Very small because we have a very large n. So we're dividing by a very large number and then taking the square root of that quotient. So it's really getting small. Really getting small. Okay, so now we're going to take our p-hat and add and subtract this margin of error. So 0.633 minus 0.011 and 0.633 plus 0.011. Now, it did not ask us to write an interpretation, but I'm going to do that anyway. I'm also going to show you the other way you'll see these answers appear. In the first problem I showed you with parentheses around the two values, you'll also see it as an inequality. I like the inequality because it does tell us that we are looking for the population proportion. You put a P there for proportion. And this is saying that this unknown population proportion falls between these two values. So I do kind of prefer the inequality method, but you're going to see them both ways. And I'll accept both ways. So the interpretation here will be with 95% confidence, the proportion of women who, let me take it right out of the problem, change their nail polish once a week, falls between 0.622 and 0.644, or about 62% and 44%. Okay. Now I've got a little bit of a different one going on here. Emergency room visits. Okay, you wish to estimate with 90% confidence the population proportion of U.S. adults who made one or more emergency room visits in the past year. Your estimate must be accurate within 33% of the population proportion. Okay, you've got no clue what's going on. You're just trying to, you want to make a survey. Okay, you're going to survey adults, and we're talking about U.S. adults. And again, there's hundreds of millions of them. So we can't ask everybody. No way we can ask everybody. So we're going to do a sample, but we don't know how many we even need to choose to actually get an accurate sample. And there, and so we're going to do some math here to determine what that value is that we need to find. So we are asked to find a minimum sample size. A minimum sample size. Another way we can say that is how many. How many do we need? How many? So this leads us to the formula, again at the top of your pink sheet, for N. N is our sample size, and we use this formula when you are asked the question, how many? Okay, let me go to my sheet where I wrote it a little better. So this is our how many question, or minimum sample size. That's how it's going to be worded when you know you have to find N and you have to use that formula. So it's got many of the same letters variables that we were looking at before. We still have a Z, we still have a P and a Q, and we have an E. Remember, E is your margin of error. So that's the other tough thing to figure out here in this kind of formula. E is our margin of error, But in this formula, it's not given to us as, here's the margin of error. It's given to us in words, so we have to pull it out of the problem. So I'm going to go back and look at what they said. It says that your estimate must be accurate within 3% of the true population proportion. Within 3%. That's a key word, that word within. When you see that word within, that's telling you what the margin of error is. So a key word. So our margin of error is the 3%. All right, let's get this formula written down and start working on letter A here. So N equals Z squared times P times Q over E squared. All right, well, we know what E is. E is the 0.03. E equals 0.03. All right, we'll square that. How about Z? Z is our 90% confidence, so we have to go to the table to find Z. At 90%, and then all the way down to the bottom, 1.645. So our Z is 1.645. Now, P and Q. Well, they don't have hats on them, so they are actually the population proportion and its complement, which we don't know. We have no clue. We don't have a clue. So we have to make a guess, and an educated guess, or we have to use something there. We can't use the number 1. That would be too much. It's not 100%. That would equal 100%. We don't want that. We don't want to just randomly choose something. So we have to use something that kind of balances the P and the Q, so that we have, the best estimate that we could come up with when we don't know anything. I don't know if anybody remembers that from last time. 50-50, yes. So we're going to consider P and Q both 0.5. And this is because we have no preliminary estimate available. We don't know anything about our population proportion, so we're just going to have to make a guess. And the best guess is always 0.5, 0.5, or 50-50. So here's the formula then. 1.645 squared times 0.5 times 0.5, all divided by 0.03 squared. All right, let's see what that looks like. So 751.67. And since we are doing a survey, we don't want to, have any decimal numbers here. I can't survey 0.67 people. So every time we do this kind of problem, we're going to round up. So 752 people would be in that survey. We always round up. Now that's again with no estimate available. Of course, in letter B, they're going to give us an estimate that we can use. So letter B says, we're going to find that minimum sample size again, so we're still looking for N, but we're going to use a prior study that found that 20.1% of U.S. adults made one or more visits to the emergency room in the past year. That's a lot of people. 20.1%. Wow. All right, so that's going to be our P that we're going to use. Our P and our Q then are going to come from there. So we're going to use a P of 0.201. Therefore, our Q will be 1 minus that, or the complement, or 0.799. Again, you can add those two up, make sure that they equal 1. And I don't think that we'll call that a hat right now. Everything else is going to remain the same. So N is going to equal 1.645 squared times 0.201 times 0.799, all divided by 0.03 squared. Okay, it is a little bit less than the original number. And again, we're going to round this up, so 483. So if you really had to call this many people, random selection of people, it would definitely, you'd have to pay a company to do that or figure out a way to do that, and it would definitely save you some money because I'm sure they charge you per call. So when you, in letter C it says compare the results, that's what we're talking about, that it's a much smaller, not a much smaller number, but a smaller number to use when you have a preliminary study than if you are just making a guess without any preliminary estimate at all. Okay, let's see what else I've got for you. And another one of these. So two of each kind that you're going to be faced with. Ice cream. You wish to estimate with 95% confidence the population proportion of U.S. adults who say chocolate is their favorite ice cream flavor. Your estimate must be within 5% of the population proportion. Okay, so I see important things there, that within 5% and the 95% confidence level. So I know, first of all, that my margin of error E is going to be 0.05. And with 95% confidence, I already know, I could look it up again, but I already know that's 1.96. You'll get to where you are familiar with some of these numbers. I mean, we only use a few of them repeatedly, so it's not something you have to find every time once you get to know this. And letter A also says that there's no preliminary estimate, so we're going to use our 0.5s. So N will equal 1.96 squared times 0.5 times 0.5, all divided by 0.05 squared. And we get 384.16. Just to remind you, in this particular case, we always round up regardless of what our decimal number is. We want to make sure we have enough so we get that margin of error that we're looking for. If you go a little bit lower, we might not get that margin of error that we need. So we'll go ahead and, to be safe, round up. Always round up. So 385 people will be in our survey. And then we have a prior study that tells us that 27% of adults say that chocolate is their favorite ice cream. So letter B says we're going to use that 27%, I'm sorry. So everything is the same except RP and RQ. So 1.96 squared times 0.27 times 0.73, that's the complement, adding all divided by 0.05 squared. $302.87. And rounded up, that'll be 303. 303 people. Okay, so in review, we have these formulas that we are using in this section to find a confidence interval for the proportion and how many when we are solving for the sample size. So these formulas come from the top of your reference sheet. And you can put some, put some things on your reference sheet to help you out, just no examples, but you can put some identifiers on there about how to know what to pick. Again, just no examples. So next class, we're going to be looking at these two confidence intervals, okay, where we still have a Z, but we also are going to introduce a new one called T, critical values. And then we'll find we have a new formula for N as well. But today's lesson, confidence intervals for the proportion. Okay, I hope you will go back and view this when you need to be reminded. I hope this thing continued to record while I was... I'm going to be very upset if it didn't.